let's start this lesson off by reviewing a concept that we already know how to do. Okay? Let's start this lesson off by reviewing a concept that we already know how to do. How do I solve this equation? How do I solve this equation? I just square it? What do you mean by that? Square both sides, right? I need to square both sides of the equation. Square this side, square this side. What happens on the left side of the equation when I square it? It's just x. Okay? What happens on the right-hand side when I square it? Is that the answer? How could you know for sure? You could check it. What's the square root of 25? 5. It's right. You already know how to do that, right? Okay? So, there's something I showed you a couple weeks ago. You even wrote it down. But I'm betting, if I was a betting woman, I would bet a lot of money that you don't remember it. Because what I told you when we wrote it down is, I want you to write this down right now so we have it written down, but I'm not going to show you what it means or tell you about it until later. Well, today is later. Okay? So I would like you to get out your exponent foldable for me, please. Take out your exponent foldable. Can I see yours? Thank you. On the very, very, very last page of the exponent foldable, we wrote this. A to the m over n power. She writes kind of big, so this is really an exponent, right? A to the m over n power. The numerator is the power, the denominator is the root. Do you have that written down on your exponent foldable?
Yes.
Good. Keep that out for now. This is what it was. A to the m over n. And I told you the top was the power and the bottom was the root. Right? Okay. Well, you kind of need to know what that means, right? So here's an example of how we might use it. X to the 1/2 power equals 5. Well, what does this mean? The square root of x, right? What does this mean? If the top is the power and the bottom is the root, that means the square root of x. It's a different way to write the square root of x. The bottom is the root, so that's a square root. The top is the power. X to the first power is just x. These two things right here mean the same thing. They're just written in a different way. That should give you some confidence if you know how to do this problem, because that means you also already know how to do this problem. We need to have a conversation about the vocabulary we're going to use to do these problems, though. Fair enough? Now, does everybody understand that this does not mean x times 1/2? Everybody okay with that? This means x to the 1/2 power. Okay? If it's being raised to the 1/2 power, I need this exponent right here to be a 1. How could I make this exponent be a 1? I can't just poof make it a 1. I have to do some sort of operation to it to make it become a 1. Have you guys ever heard of a reciprocal? What is a reciprocal? Yeah, you're showing me with your hands, right? We go like this. We flip it over. So what would happen if I multiplied this exponent by the reciprocal of itself? I would get 2 over 2, which equals what? 1. Has it done what I needed it to do? So if I raise this side to the power of its reciprocal, what do I have to do to this side? Raise it to the same power, right? Well, you just told me what happened right here. That's 2 over 2. So that ends up just being x. So I have a power and a root. Typically, we'll start with the root because that makes the problem easier. What's the first root of 5? If we're doing square root, it's what times itself, right? So if it's the first root, we're saying what equals 5? 5, right? What's 5 squared? Oh my gosh. We got the same answer. Should we have? Yes, if they meant the same things, and guess what? They do. Okay? Now, are they all as easy as that? Of course not. If it was, everyone would be math teachers. Sorry, this needs to be 54. Pretend that's a 54. What should I do first? I have to isolate my variable first, don't I? So if I divide 2 on both sides first, what do I have left on the left-hand side? X to the 3/4 equals what? 27. Now what's the reciprocal? 4/3. And if I raise this exponent to the 4/3 power, what do I have to do with this exponent? 4/3. 4/3. That didn't even make any sense. I'm sorry. 4/3. Or 4/3 power, right? What's left on the left-hand side of this equation? Now, I know that you guys want to do this in your calculator, and I'm not going to let you. Why don't I let you do stuff in the calculator? Because I need you to know how to do it in your head first. You know, then I'll let you do it in the calculator, right? Okay, so think about this with me. What's the cube root of 27? What times what equals 27? 3, right? 3. What's 3 to the 4th power? 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 3 times 3 is 9. What's 9 times 9? 81. Done. Now, just for practice, so that you know that I'm not a liar, I'm going to say 27 raised to the, I'm going to give myself a fraction, and say 4/3 power. Oh my gosh. Now, that only works if you remember which one's which. Which one's the top? The power. And which one's the bottom? The root. Which one should you start with? Does it matter? Okay, let me show you. Actually, I can show you in about 14 different ways. Here's one of the ways. 27 to the 1/3 power raised to the 4th power. What do I do when I have an exponent raised to a power? What do I do with those numbers? I multiply, right? I multiply. A power raised to a power. Power of powers. You can look on your exponent foldable. You got it right in front of you. Power of powers. We multiply, don't we? Okay? If I multiply this, I would get 4/3, right? What if it was 27 to the 4th power raised to the 1/3 power? It's still the same thing. It's still 27 to the 4/3 power. So does it matter if I do the root first or if I do the power first? No, it doesn't. Okay? Now, logically, does it matter? Do you know the 4th power of 27? I don't. I'd definitely have to use a calculator for that. And then after that, it would be a big number that I would have to take a cube root of just to get 81. That's not something that I can necessarily do in my head. I would need to do the root first to make this number smaller to begin with, right? And then I can raise that number to the 4th power. Does that make sense? Are you lying? Okay. Question so far? So what if it's something like this? X to the 2/3 power equals 20. X to the 2/3 power equals 20. What should I do first? Reciprocal? 3/2, 3/2. Following the rules that we just did, what is the square root of 20? There's not a nice even number, is there? So what should I do for my answer?
Leave it. Run away. Burn it. Kill the fire.
Maybe we should use the power first.
Do you know the third root of 20? It's 8,000. Do you know the square root of 8,000? Yeah, I don't know either, right? So it honestly, at this point, depends on the directions. It depends on the situation that we're in. Okay? This is a perfectly fine answer. Okay? However, I have my friendly neighborhood calculator here that I could say 20 raised to the 3/2 power. And it would tell me that it's 89.443. Right? If it said round to the nearest thousandths, I would want 89.443. Now, this might blow your mind a little bit. Are you okay with that? What if I wrote it like this? Or maybe it was multiple choice or something. And what if it said this? Is that also the same thing? Where did the square root sign come from? Because it's the square root. The root is 2. That's a square root, isn't it? And I actually calculated that the cube root of 20 is 8,000. It depends on the directions. Or if it's multiple choice, it depends on what answers you're given, doesn't it? Okay? I will make it clear. I promise. I will make it clear what I want. Fair enough? Okay. So let's do some that are actually things that we have to solve. Okay? Oh, wait, is that the right answer, by the way? Is this the right answer? How could we know that for sure? So if I said 89.443 raised to the 2/3 power? Huh. Boom. Right? Now, honestly, I expected this to be like 20.00000123 something. Why did I expect that? Because we rounded up, right? I guess the calculator's being friendly to us today because it just told us maybe it just was close enough to 20 that it felt comfortable. Yeah, my calculator's my friend. Okay, sometimes it lies to me, though, if I ask it the wrong thing, right? Okay, so you just got to be careful with that. What about a problem like this?
Stop it. Cannot take anymore.
I got Kleenexes on my desk. Can we? Why not? Because it's inside the parentheses. I can't do like I did on this other problem where I divided by 2 first, could I? Because right here, the only thing being raised to this power is the x, isn't it? Excuse me. The thing being raised to the 2/3 power is that whole x plus 5. That's why it's purposely in parentheses, isn't it? So what do I do first? We can just do reciprocal, can't we? 3/2, 3/2. X plus 5 equals, what's the square root of 16? 4 raised to the 3rd power? 64. Yeah. How do I solve for x? Yeah, oh, good. X equals what? 59. Is that the right answer? You're positive? We should. 59 plus 5 raised to the 2/3 power.
Good.
We're confident that's right, right? Okay. X to the 4/3 power plus 81 equals 0.
We can subtract that.
Yeah, we can, right? We need to. In fact, here's a place we do need to isolate the variable before we go on. Now reciprocal, good. 3 over 4, 3 over 4. If you let this problem be confusing, it will. What's being raised to the 3/4 power? Negative 81. So knowing that the calculator does the order of operations, what should I put in here? Parentheses. Negative 81 raised to the 3/4 power.
No.
Close. No real solution. Why is it no real solution? What kind of root am I trying to take? I'm trying to take an even root. Can I take an even root of an odd number? Excuse me. Let me say that again. Can I take an even root of a negative number? No. Okay? Because it's saying what times itself times itself times itself is a negative 81. That's not going to happen because I know even roots are going to give me a positive number, aren't they? No real solution. You can't just put no solution because there are solutions, aren't there? But they are imaginary. Like you said a minute ago, they're imaginary. Okay? This is also acceptable. Whoops. Yeah. As long as you put real, you can't just put not fam. That's different. Okay? Not real fam. I am an original G.
Oh, no.
Yeah, I know I'm not. It's okay. Yes, excellent. Questions? Anybody have questions? Okay. 27 to 32 is what you have for homework. That's 6 problems. Can you commit to doing these 6 problems by yourself? You can work together if you want, but you know what I mean by yourself. You do the problems, right? Okay. Peace.